today's the 3rd, and Thursday the 3rd, we're going to be talking more about Chapter 3, and then Tuesday of next week, we finish up just a few loose ends. Really, this may even not take the whole class on the 8th. Then Thursday, a week from today, is Quiz 2, which obviously will have Chapter 2 and Chapter 3. Okay? Okay. There's your topics again. Where did you leave off here? I know where we left off. Right here. We're going to go to the PowerPoint. Anybody has a PowerPoint? We're going to go to slide 3. I'll make sure you get some of these words that you're familiar with. One of the things we talked about on Tuesday was when the coefficients, the numbers in the objective function, change. They either go up or down. They're either representing cost or profit or something that's being maximized or min. The numbers in the objective function. Those numbers, when they change, and you see that range it can go up and down to and not change the optimal solution for the variables, that's called the range of optimality. So if you see anything about optimality, range of optimality, is all about those objective function numbers. Now, I've noticed a lot of material refers to the optimal solution a lot. It says, and this will change the optimal solution, or, and that will be the optimal solution. When it refers to the optimal solution, it's referring to, let me get an output here. I know it's kind of dark, but these values are the optimal values for the variables. That's part of the optimal solution. And that objective function value, which is the result of whatever you are maximizing or minimizing, that's part of the optimal solution. So, when you see things in the book or on the PowerPoint referring to the optimal solution, it could be referring to that objective function value, or it could be referring to these values right here. You just kind of got to figure it out, get used to it. And if you have a printout right now of the PowerPoint, as we go through a couple of slides that does refer to the optimal solution, I'm going to be more specific and let you know what it's referring to, the objective function value, or is it those values, the optimal values for the variables. These are the optimal values for the variables, that's the objective function value of time. So, now, we got that all cleared up. We're going to go to slide 15. Whenever we're talking about on the output, the constraints right-hand sides, and they could go up or down, and if they stay within those limits of how allowable of how much it could go up or how much it could go down, those dual prices are either still valid or not. All that conversation about the right-hand sides going up and down is called the range of feasibility. Matter of fact, this slide just calls it the feasible region, but it's really the range of feasibility. This is important because we're heading to a part of this where called the 100% rule for feasibility. And you've got to realize that rule, the 100% rule for feasibility, is all about the right-hand side of the constraints. But we're also heading to the 100% rule for optimality. And that 100% rule is all about the changes in the objective function numbers. So you've got to make that connection that optimality means objective function, feasibility or feasible region means the constraints right-hand side. You've got to make that connection, or you're going to read a question and may misinterpret it. Now, here we go. Range of optimality, range of feasibility. We're going to slide 21. Here's an output. Here's our sections. Here's our objective function value, our optimal solution for the variables. Here's our constraints. There's slack or surplus, and their dual values, sometimes called dual prices, sometimes called, Excel calls it something else, shadow price. I've got to add shadow price. It's the same thing. Excel calls it shadow. One of the softwares call it dual value, and another software calls it dual price. All the exact same thing. This section is the numbers that are part of the objective function, called the coefficients, those numbers. And this objective function section whatever those numbers that are with the variables in the objective function get multiplied by the optimal solution for the variables and added up, and that's how you get that objective function value right up there. So it's these numbers times the corresponding values equal that, added up. And then this last section, this is your range of feasibility. This is all about the right-hand side of the constraints. This is what the right-hand sides could go up or down to, and determine whether these dual values are still valid or not. Let me make that connection again, because there's a few people that weren't here on Tuesday. The changes in the objective function is all about whether these optimal values for the variables are still valid or not. So the connection is objective function, whether these are still valid. But these right-hand sides of these constraints, it's all about whether these dual values are still valid or not. So it's all about, do these changes, is this change is enough that these are no longer valid or not? Are these still valid? So I've had people look at this and tell me if these are still valid or not. That's not the connection. This is to the dual values, the objective functions to these. Now, we've ended the last lecture at where people start to go, whoa, what's going on? It starts to get hard. And that's where when you have a change on the right-hand side of a constraint, and you have to determine, by using this dual value, whether you'd be adding or subtracting to the objective function based on whether it's a max or a min, and whether you want to have a positive effect or a negative effect. And I need you to get out of the mind frame if you think, oh, this is a positive number, I'm adding, this is a positive number, I'm adding, or if it's negative, I'm subtracting. Because that does not mean that. These numbers, these dual values, or shadow price, or dual price, same thing. Positive one means a positive effect. Negative dual price means negative effect if the right-hand side is going up. That tells you the effect if it's going up. If the right-hand side is going down, it will have the opposite effect of what this says. Now, my hint to try to figure out whether you add or subtract is, I say these two sentences, and I forgot them right now, they're coming to me though, hang on. If, we'll see, if it's a max, a positive effect equals add. You add to the objective function value. If it's a min, a positive effect equals subtract. And then you take these two sentences, and every scenario, you're going to go, okay, you're going to get to the point to where you can say, am I going to have a positive effect or a negative effect on what's going on here? And then you're at the point whether you should add or subtract, and you're not confident, you're not sure whether you should add or subtract, jump to these two sentences and use the logic. For example, you got to the point to where you go, I know this is supposed to have a negative effect, and I know this is a minimization, but this doesn't tell me anything about negative effect minimization. But it does tell you about a minimization positive effect. So if you have a minimization problem, you're trying to figure out whether to add or subtract, and it's a negative effect, would you add or subtract? Nobody saw that coming. You can tell. You ready? Look at this. It's a minimization problem, and you want to have a negative effect. Do you add or subtract? You got it. This says minimization problem, positive effect is you're subtracting. So if it's a negative effect, you do the opposite. That's how you use these two. Just use logic, those two, that's all you need. And then you just figure it out from there. Let's start with range of optimality. Are you ready? Just kind of review, but here we go. I know some of you don't need to hear it again. This is a maximization problem, and the profit associated with standard golf bags, S, is $10. But we just found out that it's going down to $8. We're really only going to be making $8 per standard bag. My question for you is the optimal values for the variables 540 and 252 still valid, yes or no? Yes. Why? I don't think everybody can hear you. Because the allowable decrease is what? Keep going.
It's 3.7, so your equals will fall within that range.
She's saying it decreased, so she's going to compare the decrease that's taking place to the allowable decrease that will determine if those are still valid. I said it's going from 10 to 8, which is $2 decrease. It could go down $3.70, and those are still valid. Now, anybody, It says, if yes, if those are still valid, show your work calculating the new objective function value. Show me your calculation work for calculating the new objective function value. What do? There's two different ways to solve this. Any one of the two ways right now. Josh, I thought you gave me that one.
That's a blank.
Okay, I got misinterpreted. Go ahead. I'm sorry, Jason.
Okay, I could be wrong, but when you like multiply that by the dual value.
Multiply what by? No, stop. We gotta stop right there. Dual values only go with the right-hand side constraints. We objective function. This is the most common mistake on a quiz. It's exactly that. It's very common. The objective function numbers are always about the optimal
So
values.
when you multiply what you just increased by.
No, this didn't increase. It went from 10 to 8.
Decrease, I'm sorry.
$2 decrease. She's saying. Then multiply by,
By the S.
which is
So
540.
540.
So $2 times 540. What do you do then? Oh, come on. It decreased. This decreased.
So you
Subtract it, whatever that is, from the current objective function value. Exactly. When this increases, you're adding. When this decreases, you're subtracting. It's not like dual values where you got to figure out positive effect or negative effect. This is real easy. One of these are increasing, you're adding. One of these are decreasing, you're subtracting. But a lot of you are embracing the other way to solve it, which is just right now. That's 10 times 540, 9 times 252. If that goes to 8, you could just recalculate. 8 times 540, 9 times 252, and you'll get the exact same answer compared to doing it the other way, where you just take the difference and either subtract or add. Either way, whichever one you find easiest, they're going to get you the exact same answer. Just show your work. So I'm asking, however you calculate it.
So you did 2 times 540, what'd you get?
Yes. No, yes. This 10 went down to 8, which is a $2 decrease in price, profit. There's 540 of them. That 540 is still valid because that decrease was in that there, so we can count on that 540. 2 times 540 is 1,080. Because that was going down, we subtracted.
But if it was no, then we would just have to write no.
She's saying, what if this question would have said, this 10 is going down to $6? Is that what you mean?
Yes.
It's going down to $6. And the question's going to say, those optimal values still valid, yes or no? No, I heard all over the place here, but why?
Because it's exceeding the allowable decrease.
That's right. You got to put something about it's outside the range, it's outside the limit, it's out below what you say. It's below $3.70 amount that could have decreased. Be careful with that because if you accidentally use the wrong number, you're losing points when you were absolutely had the right logic completely on it. I always go with only the amount of detail you have to put on it, just to, so you don't make an exit. But basically, you do need to mention as to why it is going to change. It's no longer valid. 540 and 252 are no longer valid. Going from 10 to a $4 decrease is more than the allowable decrease or the range or the limit. And so these are no longer valid. This problem has to be redone. Now, as a safeguard, if you don't feel 100% confident, there's nothing wrong with recalculating the objective function as just a safety net. Because if you say, no, these are going to change, they're not valid, and you may accidentally looked at the wrong number, and there would be a new objective function value, that's far too many points to lose because you accidentally looked at the wrong number. So I told us the other section yesterday, when you have this situation where you're saying no, maybe go ahead and calculate the new objective function value anyway. It's only going to take you another couple seconds, and it's kind of safety net in case you made a mistake there. Because that's too many points to lose on just because you thought it was outside the range.
Can you go over one more time?
You ready? We're going to do
Yeah.
another one. We're staying on objective function, right?
Yeah.
Okay. The deluxe bag is going to earn more profit than we expected. Matter of fact, we're going to get $11 profit instead of $9. You ready? Is the optimal values of 252 and 540 still valid? Yes or no?
Yes.
Yes. Why? Let me see. What did I say this is going to? 9 to 11? Is that what I said? 9 to 11. So what did you look at to decide those are still valid?
Allowable increase.
Allowable increase, which was 5 something. It went up how many dollars? 2. It could have went all the way to $14 and it went up to 11. So those are still valid. Now there's two ways to give me the new, if you say yes, it's still valid, there's two ways, now if I can do this no matter what, actually. Give me the new objective function value. Which way do you want to do it? Anybody, which way?
So how do you know it's in the range?
It went up $2, so you gotta look at the increase it could have went up. If this were going down, you gotta look at the decrease it could have went down. It went from 9 to 11, which is $2. It could have went up $5. Be careful. Were you here Tuesday? No?
Yeah, I was.
Okay, be careful, because this one says the amount it could increase. The other software says upper limit, which would say 1428 something. So you got to look at it a different way. And the Excel, I can't remember, is that the amount or the upper limit? It's probably the amount of increase on Excel. So, you know, these all are giving the same information, but different ways. So you've got to get familiar enough to look at the words and determine what am I being told here.
But what?
Let's keep going. I'm sorry. Go ahead.
Well, whatever Zane has is still two, right? If it goes 14.
Yeah, that's right.
then it-
If this says 14 something, well, this went from 9 to 11. You're comparing the 11 to 14, but since it says 5 something, you went, oh, 9 to 11 is $2. That now you're comparing the 2 to that. You just have to know, am I comparing what it went to, or am I comparing the amount based on this title up here? This is the amount up here, but the other one says upper limit, so you're looking at what it turned into. Now, we got to get the new objective function value. It went from 9 to 11. The other one didn't change.
11 times 252.
11 instead of 9 times 252, then, no, come on, wait, then,
And
no, stop.
Subtract.
No, stop.
Wait.
Stop. Is this being recorded? I don't have time to edit this out. Hang on.
Wait.
Stop. You add or subtract if you're doing the amount of the change, but he was using the new price. He wasn't using the $2. He said 11 times 252 plus,
I didn't say that.
Josh, what'd you say?
I just said
Who said 11? So help him out. 11 times 252 plus 10 times. It didn't change, it's still 10. This one went from 9 to 11. And this is 9 times 252. If this goes to 11, it would be 11 times 252 plus 10 times 540. The other way, Jasmine, you like the other way, right? What's the other way? You're going to take what? 9 to 11,
So you do
2 times
252.
252, add or subtract it. Add it because this went up. Very good. That's the add or subtract way. It's
Add
about
10.
the amount of change.
Add 10.
What are you adding it to?
Are we adding?
Oh, you're adding it to the objective function value.
Oh.
So 2 times 252 added to that. All the questions are about what this will turn into with all the changes. Even the right-hand side is all about what that turns into. Because we're making our decisions based on this maximum profit or minimum cost or what this is. We're making a lot, we're about to learn how we're making a lot of decisions based on this too, the dual values. This is a big part of manufacturing or buying if you're a purchaser agent, because you're getting hit with offers from vendors all the time. They need decisions fast. This is where you're going to look, right here. That's where we're at. Okay.
Either way would give you the same answer.
Either way gives you the exact same answer. Either way. We're going to do now some constraints. Range of feasibility. This is where it starts to get tricky a little bit. Again, this will help us. So you just got to get to the point now where you say, this is going to have a positive effect or a negative effect. So here's the review. These dual values represent the positive or negative effect amount for every 1 unit the corresponding constraint right-hand side goes up. That's in stone. That represents the corresponding value if it goes up 1 unit. If 630 goes to 631, it's going to have a positive effect of that amount to that. We don't know whether we add or subtract. We're not there. We just know it's going to be a positive effect. If this 630 goes down 1 to 629, it's going to have a negative effect, the opposite, 1 times that, and then we've got to figure out whether we add or subtract. Negative effect, though, because it went down, not up. So the opposite is going to take place. Everybody with me? Now that we said that, jump into it.
How do we know if it's a maximize or minimize?
I will not leave you hanging.
All right.
It will say in that question, because it's not on the outputs. It never is. It's on the software though, when you're entering all the data, it will say right at the top, max or min, but when you hit solve, it disappears. Yeah. So, but believe me, when I write the question this weekend, I'm writing your quiz, or most of it, I'm going to make sure you know if it's a match or a min. You will, as soon as it starts. You ready? We're doing the right-hand side, range of feasibility. Here we go. Constraint 3 had, we just found out that we don't have 708 hours there. We really have 800 hours. 800 hours. Is the corresponding dual price or dual value still valid? Yes or no? Yes. Why? Yeah, and you've got to put something there. Why? Hit me again. I heard it somewhere.
Because it can increase one.
How much is it increasing, by the way?
92.
92, and it could increase
100.
192. That's still valid. Now, you ready? This increase of 92, 98, 92, is it going to have a positive effect or a negative effect on the objective function value? Positive effect or negative effect?
Positive.
Positive. Because it's going up, this represents the effect, and for each one unit. So, positive effect is correct. Now you're multiplying what?
92.
2 times.
6.6.
Exactly, 6.93750. Are you ready? This is a maximization. Look at your notes. Add or subtract? Add. Positive effect, max problem, you add. There you go. These are too easy now, right?
So 92 times.
Uh-oh. We gotta do another one.
Just reset the savings.
Okay, ready? Chris, are you ready? I want you to help me. You're not ready?
I'm soaking it in.
No.
What are we calculating? What's
The new objective function value.
Okay, cool. That makes sense.
What that's going to turn into, because of this decision that we're going to take, that we have these extra 92 hours. Positive effect is going to increase our bottom line. We're all about it. Even if we got paid overtime, we can now measure the effects and decide if the cost justifies it. All right, you guys, you ready? You ready? We don't have 630 hours in the first department, constraint 1 anymore. We only have 600 hours. Is the dual value for that constraint still valid? Yes or no?
Yes.
Because it went down how many units? 30. You're comparing it to what number?
134.
The level decreased because it decreased 30. So it's within there, right? The dual price is still valid. What kind of effect is it going to have on the objective function value? Positive or negative? Negative is absolutely correct because if this were going up, it would have a positive effect. But it's going down 30, right? 30? I forgot already. So it's going to have the opposite negative effect. And this is a minimization problem. So are we adding or subtracting? Okay, well, there were 2 different answers all over the place here. Hang on, go back. Let's say it again. Ready? This is going down. It has to have the opposite effect. So not positive, but negative effect. It's a minimization problem. Negative effect. Look at me. Add or subtract?
Add.
You're all on the same page now. Add. Because positive effect can be subtracted from the minimization. I said negative effect, so you know it's got to be the opposite. Okay. You feel like we're okay? Can we go on now, or do you want to see another constraints, objective functions? You see the changes and how it's going to.
So you don't have to look at the max or min to determine adding, subtracting.
Oh, you do. If it's a change here, you have to look at whether it's a max or a min to decide whether you're adding or subtracting. Yes, yes, yes. That's what that was all about. Let's do another.
Okay, but I thought you said when it's negative, you add. So
When it's a
positive.
minimization objective function, and it's a negative effect, you would add. Because that means it's probably a cost and a negative effect on the
But
cost.
it's the opposite when it's max.
If it's a maximization problem, negative effect would be subtraction. Because that's probably profit. Negative effect is profit goes down. We good? You want to do one more? Because this gets harder. I don't want to be without enough time. You ready? I got you back. I think I got everybody where they're ready for it getting a little harder. This is more common in real world. First of all, I want to make sure you understand real world. Hang on. Real world situation is just like this. General Electric said they recently used linear programming. They had 3,100 variables, 1,100 constraints, and they were able to solve it in 10 seconds to figure out the optimal solution for 3,100 variables. This is how it's used. This is how I'm trying to get through to you guys is the concept on a micro scale, just so you can see what's going on, all right, how it works. I want you to realize in the real world, it's, you know, I've had 50 constraints and 20 variables, and it's just a matter, you got to realize if this only works as well as the person who's coming up with all the input items. And that's why you're having to learn all this kind of manual stuff, because you need to be able to come up with the correct inputs for this to even work. That's what if you blow one input out of 3,100 or 1,100 constraints, you're going to get an answer. And then you're going, oh, that wasn't even, why did you do that? All right, we're going now back to, this time we're going to this output. Here it is, right? Remember how to input this? You said linear programming, new, and it said to you how many variables. You said how many variables? No. Two. Then it says, is this a max or a min? I think it's a max. We'll call it a max, right? And then it says how many constraints, and you answered, very good. And then it opened up and it looked like this, and it had x1 and x2. You went up and changed it to s and d. You looked at the problem, you said, oh, it's 10s with the s, 9s with the d. They're all less than equal. You don't have to put the equal. It's just less than. It's assumed equal. There's the right-hand side. There's the numbers with each variable. 7 tenths. There's 1, a 1, blah, blah, blah. You click Solution. Don't forget, this is posted on Blackboard under Course Information. It's a zip file. The instructions say you click on it. Remember where you saved it. Go to where you saved it. Well, have a folder somewhere you can extract it into. Once you extract it into the folder, that's where you'll see this. Yeah. Once you extract it, the folder looks just like this. You want to go to this file right here. I know you've heard this a couple times, but a lot of people want to make sure because they're going to get frustrated. You right-click on that. Don't double the left click on it. Right-click. Just like this. And the first time you run it, or as soon as you get the error message because you forgot, go back, right-click, run as administrator. You only have to do this once. And after you do this once, it works every time after that, unless you reinstall it or something. But just one time, you got to run as administrator. From that on, you just double-click right there. It runs. And now, let's solve it. Solution. Solve. Here's our output. You ready? Finance just walked in. We started production. We're on our way to making 540, 252 of our standard and deluxe bags. But they said, hey, you are going to believe what happened. We're going to end up making more profit than we expected on these. As a matter of fact, the standard bag is no longer $10 profit. It's $11 profit. And the deluxe bag is no longer $9 profit. It's $12 profit. Now, let me write these down because my numbers suck. 10 going up to 11. 9's going up to what I said? 12. Thank you. My question for you is, are the optimal values for the variable still valid, yes or no?
Yes.
How do you know? Tell me.
Because the limit.
What's going on? This is going up to 11. What are you looking at?
13.
Upper limit. This is different. It's different than the other one. The other one was allowable increase. This one's upper limit. So you're comparing the result instead of the amount. You're not the 1 unit's going up, but the result of 11 to 13.5, and you're saying it's within the upper limit. You need to write that that's within the upper limit as part of your answer. You're looking at the other one, 9 to 12. And this says the upper limit is 14. You're saying, oh, that's within the upper limit. You can, if you want to say they're both within their limits, because one could be in one direction, one the other, I'll accept that. But you've got to tell me what you're looking at to say yes or no. And then I'm going to mark it wrong unless you did the 100% rule. You ready? Anytime there's more than one change in a certain area, whether it's the objective function or it's the constraint, in this area, if there's more than one change, you must do the 100%, calculate the 100% rule. Everybody hear that? You start by saying, you look to see if the change is within the limits, and you say both changes are within the limits if they are. Because if one of them are not within the limit, these are no longer valid. You say the optimal solution is no longer valid. In this case, they are both within their limits, you told me. So you write both changes within the limits. But do not say yes, those are still valid, because you've got to measure the amount of change compared to the amount it could change, and compare that to 100%. You ready? Here we go. I know, I'm losing you, but you're gonna see it enough time. 10 is going to 11, which is a 1 unit change. 10 in the direction of the change is going up. How much could 10 have gone up in units? How many units could it have gone up? 3.5. We're going 3.5. Calculators, help me. Get ready. 1 divided by 3.5. Next, 9 is going up how many units? 3 units. 3 units divided by 9 could have went up how many units? No, stop. 5.28. What is that? How would it go? 857. 857. Everybody, you can't see this. I'll say it again. Ready? I have 1 unit change over 3.5. In case anybody's writing this down. And then I have the other one's a 3 unit change in the direction of the change. It could have went 5.282857. 1 divided by 3.5 is 0.29. 0.2857. What's the digit after the 7? Help me.
1.
Okay, we're good. All right. 3 divided by 5.2857 is 6.6.
5.5.
Wait, stop. What? 0.5?
Yeah.
0.67.
0.57.
No,
0.5.
0.5. 0.5, 6, 7, 5.
6, 7, 5, 1.
6.
Okay, and I'm moving the 5 to a 6.
Okay.
So 5, 6, 7, 6, 2, 8, 5, 7. I'm adding these together. I got 28%, 50, I got 29%, I got 57%. I add them together. Are they greater than or less than 100%? You must compare this to 100%. Whatever this adds up to is going to be less than, correct?
Yes.
This is less than, I'm putting an arrow here, 100%. Show the comparison. Now you can state that that optimal solution is still valid because they're both within their limits or ranges, whatever you want to call them, and you're showing work, your calculation work, that the changes, the percent of change that they're taking compared to what they could take, added together is less than 100%. If this goes over, this can be equal to or less than 100%, that's still valid. But if these would have added up to 100.1, those are no longer valid. The optimal, this has to be completely redone. Even though they were both within their limits, they combined to use too much of the allowable amount of change that could take place. Now, you need to see this again. You ready? I'm going to change it up. I need you to see, be ready for anything. I'm going to erase this. I think you got the concept. Is it getting hard?
I think it's good.
I actually like this stuff, you guys, and I'm really breaking this down and trying to make it as easy as I possibly can. There's a simultaneous, there's more than one, by the way, there could be 3 changes, if there's 3 variables, there could be 4 changes. Anytime there's more than one, however many, more than one, 100% rule. And at least 4 of you are going to forget the 100% rule if it is asked for. It will be.
What are the changes in constraint and a variable?
Nope. It's more than one change in the same area. Okay.
Even if,
About the 100% rule.
Yep, anytime there's more than one change. And I just want to make sure you realize if you're reviewing this, the 100% rule, where am I, is, I don't have the slide, yeah, slide 14, no, yeah, 14. There you go. Right here, the range of optimality 100% rule states that simultaneous changes in the objective function coefficients, more than one, will not change the optimal solution as long as the sum of the percentages of the changes divided by the corresponding maximum allowable change in the range of optimality for each coefficient does not exceed 100%. That's what we're doing. We're breaking this down, making it easier. You ready? Here we go. The profit on the standard bag has gone from $10 down to $8. But the profit on the deluxe bag has gone up from $9 to $12. Everybody hear this? All right. My first question is, are they both within their limits, yes or no? Okay, so you're going to state both within limits. Boom. And then, excuse me, yes or no, are those optimal values still valid? This is where you gotta calculate the 100% rule and show your work. Everybody's hearing me? Show the detailed work so I can see how you're getting your 100% rule. 10 goes down to 8, that's a 2-unit change divided by what?
6.3.
Why 6.3? Let me look at this. Hang on. 10 is going down 2 units to 8, you're not divided by 6.3. If that heading said allowable decrease, you're perfect. 6.3.
3.7.
No, how many, don't give me the percent yet. I don't know what you said. You said something, percent?
3.7.
Oh, is that what you said? 3.7, exactly. That is the amount it can decrease. Somebody said 3%. They jumped way ahead. 3.7, now give me a percent. 2 divided by 3.7, hit me. 0.54. That's not what you're doing? I thought you had to calculate it. 0.5. Oh, you are? Well, I thought you had it. 0.54054. What's the digit after that 4? 0. Perfect. 054. 54054. 054. Is that possibly it? Yep. The next change is going from 9 to 12, which is how many units? Wait, I want to point something out. The reason this is so correct is you recognized it was going down to, so you looked at the amount it could go down. Now, the reason I'm bringing this up because it's very common that somebody will compare it to how much it goes up, even though it's going down. And a very common mistake is somebody will calculate the whole range as the denominator, but it's only an amount in the direction in which it's going. Okay, so you gotta try to remember that. The other one's going from 9 to 12, which is 3 units, is that right? 3 units divided by how much could it go up?
2.4.
What?
No.
No, 9 to 14.
5.
5 point, I'm going to call it 5.23. How's that? 3 divided by 5.3 equals point.
0.568.
Okay? Is the optimal values for the variables, the optimal solution, still valid? Yes or no? Why? Is that Sarah? Listen. Why?
Over 100%.
That's right. 54% plus 56% is 110%, plus you got some change there, making it 111%. Way over 100%. No way are those still valid. But I could be making a mistake. I don't feel 100% confident. So what am I going to do for the new objective function value? Because that's the question. If those are still valid, you got to calculate the new objective function value. How do I do that, just in case they are correct? How do I do it? New objective function value. Hit me.
Take the new current.
Take the new current values, which happen to be 10 is now 8, and 9 is 12. You take the 10 that turned into 8 and multiply by, which is how much?
540.
540. Very good. Then you take 9 into 12. 12 times what? 252. No, is that right? No.
Times 7.
Yeah, 252. Thank you. So 12 times 252, 8 times 540. Add those together. You got the new objective function value. You want to do it the other way?
Yeah.
Here we go. 9 goes to 12, which is 3 units going up, times 252, add, because it went up. 10 went down 2 to 8, 2 times 540, subtract. After you add, then you subtract, because that one went down, that one went up. If you want to use the amount of change to calculate that new one, you would do it that way. Or, like Josh said, you just use the new values times the optimal solution. And you can do that even though you said this is over, you gotta say this is over 100%, the optimal values are no longer valid. Even though they were both within the limits. How do we feel?
So if it's decreasing, you don't do a negative 0.54?
No.
No?
No.
Okay.
No. It decreasing is determining which number you're going to use down here, because you got to compare the amount it could have went in that direction.
Okay.
All right. Same with the right-hand sides that we're about to talk about right now. This is all about the direction in which the change is taking place compared to the amount in the same direction it could take place. How we doing? I forgot what time we got. We got a half hour? Oh,
Yeah.
we're doing okay. You want me to stay on objective functions as we just
No,
read?
I just want to ask one more question. You did something about subtracting. What do you subtract?
You ready? If you want to calculate the new objective function value, one is going down, one's going up. So if you use the new value, like this is now an 8, and so 8 times, oh wait, I'm sorry. If you're using the amount, you're in that. So 2, it went down 2 units, times the 540, and it's being subtracted because it went down. So 7,668 minus 2 times that would be 1,080. So minus 1,080. Then this one went up 3 times 252 added because it went up. Went up 3 times 252 added. So the first one subtract that. This is only if you're using the amount it changed. If you're using the numbers it changed to, that's the other way. Okay, here we go. We're looking at the constraints. Same exact rule. Oh. Just wait for anything else. I didn't even say all of it. Wow. Okay. Looking at the right-hand side of constraints, and foreman, the supervisor, the manufacturing supervisor walked in and say, "Hey, so-and-so has to have the next 2 weeks off, and that's going to change the amount of hours we have because she's in 2 departments. She's in the constraint 1, whatever department that is, it's 630 hours, and she's in department 3, which is at 708 hours. So we don't have as many hours in either one of them. So 630, the 630 hours is going down to 600, and the 708 hours is going down to 600. Uh-oh. Same rule. How much is the constraint 1 in units going down? 30. What is it you're going to divide that 30 by because constraint 1 went down? What are you going to divide it by? Which now this isn't allowable. This is a lower limit. Be careful. Oh yeah. No, okay, I thought you were reading. So this is what, 134.4. Someone help me. Is that true? 134.4.
Yes.
Thank you. And then the other one's going from 700 to 600, which is what is that? 92. Anybody? 108. 108 units down, divided by the amount it could go down, which is 128, right? 708 minus 580, 128. Does that sound right? Whoops, 128. So I've got 30 divided by 134.4 equals
0.2232.
2232. 108 divided by 128. This is big.
0.78438.
8438. 22% plus 84% is that. How is that compared to 100%? It's over, which means these optimal values are what? No longer valid, bad, wherever, as long as you're telling me whatever's going on. Now let's be safe. Let's be safe. Just in case we're not completely confident that we got the right thing here, and we don't want to lose all those other points, let's calculate the new objective function value, just in case this ended up being less than 100%, we made a mistake. You ready? The first one, 630 is going down to 600, going down to 600. Positive effect or a negative effect? Positive effect or, oh wait, I forgot to write. These are both within their limits, right? Both within limits. They're now, we're pretending they're less than 100%. You gotta put all this points for every part of this. Here we go. 30 times what? Boy, I swear, I thought you guys had it. 30, going down 30 times what? The dual price, which is what? $4.37.5 times 30. Positive effect or negative effect? Negative effect, because if it went up, it says positive, so it's got to be the opposite. Negative effect. Negative effect, where is it? This 30 is a negative effect. Now, is this a max or a min? Is it a min? So it's a min. We take 30 times $4.37.5. It's a negative effect. It's a minimization problem. Do we add or subtract it?
Yeah.
Good. All right. We add it. Because at minimum, if it was a positive effect, we're subtracting. This is a minimized negative effect. We are adding. The other change is 708 to 600, which is 108 units times what? $6. 39.39, whatever. Then, is it a positive effect or a negative effect, this change? Positive effect or negative effect? Negative effect. So we have 108, which is a negative effect on a minimization problem. Add or subtract it. So we add this one, we add that one, we have our new objective function value. And you're showing me that you can interpret whether to add or subtract based on whether it's a min or a max, based on whether it's going up or down, based on whether it should be a positive or negative effect.
Is that theory, since it's negative, affecting negative?
No. Because the negative effect just trying to say you need to either add or subtract whatever would be a negative effect on this particular objective function. And we knew it was a minimization, and we knew a positive effect would be subtracting, so a negative effect would be add.
And we're adding the two? Or we're adding the...
We're adding both of them. So it'd be 30 times $4.37 added, and then what's this one? 108 times $6.94 added. So they're both going to be added if they were within the 100%. But they're, these are not. But just to make sure we got our bases covered, we're going to calculate. Matter of fact, if I can remember, from now on, I'm going to change all these questions. It's going to say, calculate the new objective function value, period. Not whether they're valid or not. I'm just going to ask you to calculate the new objective function value. So expect that you don't have to decide whether you're calculating or not. You must calculate it to get those points. Those points, whether this is a yes or a no. Okay?
But if it is a no,
You would in real life. You'd redo the problem.
the objective function would be wrong.
Wrong. The optimal solution would be wrong. It changes everything.
Yes.
So you gotta redo the whole thing.
So is this 100% rule and like all the constraint limits, does that tie into like an objective function value, like limit itself?
Well, really all it does is all these limits are what telling you that you're trying to make quick decisions. This is how this is used. Here we're at. We aren't quite there, but there's what's called sunk costs or relevant costs that we'll get into either today or next week. But what it means is you're a purchasing agent and you're working for a manufacturing company, or these are used in finance, all kinds of marketing, and you're the one who put the whole marketing together, how many commercials or TV, how many newspaper ads, and you just got a call that something changed. And you got to say, stop what I said, this has to be changed or not. When it comes to the right-hand constraints and the dual prices, you have to make decisions on these phone calls based on these values. For example, if this supplier calls and says, hey, we're no longer, we have more than 630, could you take this extra 20 units for $5 a unit? We need to know now, because we're going to the next customer if you're not going to take it. And you look at this and you tell me, do you want those extra 20 units at $5 a unit, yes or no? All you got to do is say, the 20 unit increase is within the upper limit, so that is still valid, and that's the most you want to pay per unit, because that's how it's going to affect your bottom line. If you pay more than $4.37.5, you're going to lose money on the deal, because your profit's only increasing $4.37.5. So why? Don't pay. Now, you need to be a good purchaser. I need you to go back out there in the real world and say, your answer in real life should be, no, I'm not going to take that 20 units. But if you can give me those 20 units for $4, I'll take it. Negotiate. Make a counter offer. Don't let the person move on, the supplier move on to the next customer, because you'd like to make some money off that. Matter of fact, lowball it. $3. If you give me it for $3 a unit, I'll take it. Because you know right now, that quick, if this is your decision making. All right? How are we doing? We're doing okay. We got to do another constraint real quick. I want to make sure everybody's getting this. Obviously, we're going to use this is a max problem this time. It's a max problem. Here we go. We're using constraint 1 and 3 because it's the only ones with dual values, so it makes sense. The 630 hours in the first department, in the first constraint, we now have more hours available. So 630 is going up to 645. And the other department, 708, is going down to 658. 708 is going down to 658 hours, and the third constraint, or the third department, 630 is going up to 645. Are they both within their limits?
Yes.
They are. So both in limits. Boom. 100% rule. Here we go. How much is the change in the first constraint? 15 divided by how much in the same direction the change is in could it have changed?
52.3.
52.3, is that what you said?
36.
36, okay. 15 divided by 52.36. But you're all over there. Darn.
Oh, 0.2865.
0.2865. And then the other one's going from 708 down to 658, which is how much change? 50 on the nose. How much could it have changed in that direction?
128.
708 minus 128, is that what you said?
Yeah.
128. 50 divided by 128 equals 0.4.
0.3906.
That's what I meant. 0.3906. Almost 0.4. I'm adding 29% to 39%, which equals 49, 59, 6. What is that? 60? 0.6? Is that what it is? 0.6. We are less than or greater than? Less than 100%. Right there's a quarter of a point. You've got to show me you made this far. I want everybody to see this. This is the work I need to show me you took this into consideration by writing that it's less than 100%.
It's 0.677.
Okay, I'll take that. 7. How's that? Okay? Now, you ready? New objective function value. The first one's going from 630 to 645, which is 15. 15 times what? 15 times, oh, stop. How much? 4 what? 4.3, I'm going to call it 375. And then, is it going to have a positive effect? It's going up, positive effect or negative effect on the objective function value? Positive effect, because it's going up. This is a positive effect. 15 times $4.37. Add or subtract to this maximization problem. Add. Maximization, positive effect, add. Very good. Next one. 708 is going down to 658. It's 50 units. And it could be multiplied by what number? 6.938. Very good. We multiply that. Is it going to have a positive effect or a negative effect? This is going down. Negative effect, because if it goes up, that would be positive effect. It's going down, so negative effect. Are we adding or subtracting this maximization problem? Let me say it again. Negative effect, maximization problem, add or subtract? Subtract. Maximum positive effect would be add, so this is a negative effect, and it's whatever I say, maximization problem, so we subtract it. We added this one, right, and then we subtracted this one, and there's our new objective function value. And you're going to have to calculate no matter what. You're going to have to, it could be a change here, 2 changes. You got to give me that new objective function value, even if those changes are outside the limits. You got to give me that new objective function value.
What are we adding or subtracting? Like, are we adding the
To
objective
that
function?
67667.
And then we're subtracting.
Every one of these, all these changes are all about that objective function value at the top.
So we'll have 2 answers?
No.
What
You're first subtract, adding, and then you're subtracting from where your result was. You've got to do both of them. Start at 7667 or 8, subtract whatever this turned out to be, then take that result, add this to it. There's your new value. We good? How we feel? John has this. I can feel it, John. This is the best part of this class so far. It's that easy to you. Howard or Harold, you too? Is that when you just gave a look? Oh, okay. All right, John, are you ready? Are you ready? Okay. The objective function value, which is currently 10, just went down to $8. And the right-hand side of the first department, 630, just went up to 680. First of all, is the optimal solution on this change still valid? Yes or no? The value. John, what? Yeah. Is the dual price for this constraint still valid, yes or no? Okay, I went fast. Did you guys understand what he just said? Now, there was 2 changes taking place. Do you need to do the 100% rule? No, they're in different places. There wasn't more than one change in this area. It wasn't more than one change here. It was one here, one here. 100% rule doesn't matter. He just stated that the first change within the limits, so that 540 and 252 is still valid. He said the 630 increase, whatever I said, was still within its limit, so that dual price is still valid. But be careful, because now the new objective function value, let's think about it here. You're taking, what did I say this was? 10 to 11?
8.
Oh, 10 to 8? 10 to 8 is a 2 unit times 540, add or subtract? Subtract, because it went down. The 630 is going to 680, which is 50. 50 times what? 4.37. It's a max problem, add or subtract. Is it a positive effect or negative effect? Positive effect. It's a max problem, add or subtract. There you go. I'm not going to throw a change in one area, change in the other at you on the quiz or the final. I was testing John. He needed to be challenged. All right? Have you had enough?